Right now, your heart is beating. You're not thinking about it, you don't have to. It's been doing that every second of every day since before you were born, around 100,000 times today alone. But at some point, it will stop. And in the moments after it does, something happens inside your body that science only recently discovered, something so unexpected that the researchers who found it didn't believe their own data. This is what actually happens when you die. Not the medical version, not the legal version, biological truth of what your body does in the exact moment it stops being alive. Let's start at second zero. Your heart stops. No more electrical signal. The muscle goes still. Most people think this is when death begins. It isn't. The cells in your body don't know your heart stopped. Not yet. They're still metabolizing, still burning oxygen, still doing everything they were doing a second ago. For the first 30 to 60 seconds, almost nothing changes at the cellular level. Your neurons are still firing. Your organs are still attempting to function. Your body is running on the oxygen already dissolved in your blood, already stored in your tissues. You are legally dead. Biologically, the machine is still running. Then the oxygen runs out, and this is where it gets strange. In 2013, a team of neuroscientists at the University of Michigan published a study that changed everything we thought we knew about the dying brain. They were studying cardiac arrest in rats. In the seconds after the heart stopped, they expected the brain to go quiet, to power down, to produce less and less signal until there was nothing. That is not what happened. In the first 30 seconds after cardiac arrest, the rats' brains didn't go quiet. They surged. Gamma wave activity, the highest frequency brainwave, the one associated with peak conscious awareness, with vivid perception, with what researchers call heightened states of consciousness, spiked to levels higher than anything recorded during normal waking life. The dying brain was more active than the living one. The lead researcher, Dr. Jimo Borjigan, said the data was so unexpected that the team spent months trying to find the error. There was no error. And in 2023, a follow-up study at the University of Michigan recorded the same surge in 4 human patients who died of cardiac arrest while being monitored in hospital. All 4 showed the same pattern. The moment blood flow stopped to the brain, gamma activity exploded. In 2 of the patients, it concentrated specifically in the areas of the brain associated with visual processing and memory retrieval. The areas that generate what we experience as vivid, real imagery, the areas that activate when you dream. Nobody knows exactly what those patients experienced in that moment, but their brains were doing something intense, something that looked from the outside like the most awake they had ever been. This is the most likely biological explanation for near-death experiences. The tunnel, the light, the feeling of watching your own body from above, the memories playing back, not a glimpse of something beyond. A brain using its last available power to generate experience at maximum intensity. Evolution built you to survive. And a brain that generates a surge of coherent experience in its final moments may be doing exactly that, making one last attempt to find a way out. Meanwhile, the rest of your body is beginning a different process. By the 3 to 4 minute mark, brain cells begin to die in large numbers. Without oxygen, the neurons that hold your memories, your language, your personality, your name, they begin to break down irreversibly. This is the window, the 4 minutes that paramedics race against. After this point, even if the heart restarts, the person who wakes up may not be entirely the person who went in. At the same time, something else begins in your cells. The membranes that hold each cell together start to fail. Enzymes that were kept safely inside the cell walls begin leaking out, and those enzymes do exactly what they were designed to do. They start digesting the tissue around them. Your body begins, very slowly, to consume itself. This process is called autolysis, self-digestion. And it starts within minutes of death. The cells of your pancreas go first. The pancreas produces the most powerful digestive enzymes in the body. When those cells die and rupture, the enzymes have nowhere to go but into the surrounding tissue. Your gut follows, then your liver. From the outside, nothing looks different yet. But inside, the process has already begun. Within hours, the bacteria that spent your entire life living peacefully in your digestive system realize the immune system is gone. There is nothing stopping them anymore. They begin to spread through the intestinal walls, into the bloodstream, outward through the tissue. They are not invaders. They are yours. They have been with you your entire life. They are simply doing what they were always built to do. Break down organic matter. They just couldn't do it while you were alive to stop them. Your body is not being destroyed by something external. It is being recycled by something internal. Something that was waiting inside you the entire time. Now here is the part almost nobody talks about. Your cells don't all die at the same time. For hours after clinical death, in some cases, for days, individual cells in your body are still alive. Skin cells, bone cells, some muscle cells, still metabolizing, still responding to chemical signals, still, in the most technical sense of the word, alive. In 2021, researchers at NYU discovered that certain human cells not only survive death, but actually increase their activity in the hours afterward. Specific genes associated with wound healing, immune response, and cellular stress, switch on after death. As if the body is trying to repair something that cannot be repaired, as if it hasn't gotten the message yet. Scientists call this a twilight state. Not alive, not fully dead. something in between that our language doesn't have a clean word for. The legal moment of death, the biological moment of death, the cellular moment of death, they are not the same moment. They may be separated by hours. This is why the window for organ transplantation exists. Why a heart removed from a dead body can beat inside a living one. Because death is not a switch, it is a process. One that starts long before the moment we mark on the certificate and ends long after the body goes still. Every culture on Earth developed rituals around the body that lasted hours, sometimes days after death. Sitting with the body, keeping watch, not leaving the person alone in the transition. We assumed it was grief, but what if some part of them understood that the process wasn't finished? Waiting, patient, in no hurry at all. Subscribe for more amazing content. Your support helps us continue creating valuable videos for you.